Welcome back. Today we're going to be looking at section 6.6, day 1, using the change of base formula to solve logarithmic equations. So previously, when we had to evaluate a logarithmic equation, we would set the original equation equal to x. So I have log base 9 of 27 equals x. Then we would put it in exponential form. So I would have 9 to the x power equals 27. Then we try to get the same bases. I can convert both of those to using a base of 3. 9 is 3 squared. Bring down times the x. And 27 becomes 3 to the third power. Once the bases are the same, then we can set the exponent pieces equal to each other. So I'm going to multiply there, and I get 2x equals 3. Divide by 2, and we got x equals 3 over 2. That's how we solved these previously, which is the same as 1.5 or 1.5. Now the change of base formula was on yesterday's stuff, but it's this formula right here that we need to make sure we know how to use. You want to have a calculator handy just so that you know how to type it in the calculator. So if I'm using the change of base formula for my first example down here, log base 2 of 3, when I type that in the calculator, I'm going to type in log of 3. Your calculator may want parentheses around that 3. And then it's going to be divided by log base 2. You want to make sure that you're typing this in the calculator correctly so that you are getting the same answer that I'm getting. When you type that in, we should end up getting, if we round to the nearest hundredths, 1.58. Take a moment and make sure you know where to find those keys on your calculator. When we type in log base 5 of 12, we're going to type in log of 12 divided by log of 5. Again, your calculator may want you to put parentheses around those numbers. And when we round, we're going to get 1.54. That is using the change of base formula. So now, instead of what we did previously, we can use the change of base and have the calculator assist us. So now let's go back. Solving equations review. Again, I can convert 16 and write it with the base of 2 because 2 to the 4th power is 16. So now when I have the same bases, we can just take the exponent pieces and set them equal to each other. And I get x equals 4. The problem is, on this particular problem, there's no way to get the same base. And that is where we have to start using our change of base formula. So when we can't get the same base, we have our list of directions over here. The first thing that we're going to have to do is rewrite it as a logarithmic equation. So when I rewrite it as a log equation, it's going to be log base 7 of 20 equals 3x. Now I can use a calculator to do the left-hand portion of the equation by typing in log of 20 divided by log of 7. And when I type that in, I get 1.539. And I'm going to bring down that equals 3x, divide both sides by 3, and I get x equals 0.513. Again, you want to do this on your calculator and make sure you're getting the same answers as I am. So let's try another one of these. We have 3 to the x power equals 4. Again, there's no possible way to get the same bases. So my first step is to write it in log form. So log base 3 of 4 is x. Now I'm going to use my calculator, use my change of base formula, and take the log of 4 divided by the log of 3, and that will give me 1.261. for a value of x. Next problem, we have 6 to the 2x equals 21. So when we put it in log form, it's going to be log base 6 of 21 equals 2x. So I type in the calculator, log base 6 of 21 log 21 divided by log 6 equals 2x, and log of 21 divided by log of 6 is 1.699 equal to 2x. Finish solving for x. And we get x is approximately 0.8. It says 495, but when we round that, following the directions nearest thousands, that's going to actually round to 0.85. Now we're going to work on this one. We're going to put it in log form, so it's going to be log base 3 of 101 equals x plus 4. Use our change of base here. Take log 101 divided by log 3. And we're going to get a decimal. The decimal value of that is 4.201 equals x plus 4, and then just solve for x. So we subtract 4 from each side, and we get 0.201 equals x. We're going to go ahead and move on from that one, and let's try, remember our old friend e. Now remember, e always shows up with natural log, but in this case they already have the same base. So if the base is the same, there's no need to do all that extra work. We can take the exponents, set the exponents equal to each other, and then just solve for x from there. And we get x equals 1. Anytime when our variable is in the exponent position, we need to get it out of the exponent position, but I first need to isolate the e. So in this particular problem, I need to subtract the 9 first, and I end up with 3 times e to the 4x power equals 6. Divide both sides by 3, and I get e to the 4x power equals 2. Now, e always goes not with log, but with natural log. So when I write this, it's going to be natural log e to the 2 equals 4x. We don't really need the e for the base here. That's the same thing as just natural log 2 equals 4x. And there is a natural log button on the calculator. It's an LN. Some of you are writing it as either 1N or IN, but it's an LN, and it's usually right around the log button. If you type that in, and then the number we want, in this case is 2, we're going to get, I'm going to move that over here, we're going to get 0.693 equals 4x. Finish solving, divide it by 4, and we end up with 0.173. Let's try one more of these. We're going to add 7 to both sides, and I get 2e to the 2x equals 12. Divide by 2, so e to the 2x equals 6. Now I need to type in, write this in natural log form because e goes with natural log. So I have the natural log e to the 6 equals 2x. Natural log e to the 6th, we can just type in the calculator. ln6 is what we type in, and we get 1.792 equals 2x divided by 2. And we end up with x equals 0.896.